Here we have a quadratics question, and this is taken from C1 May 2012, and this is question 8 on that paper, so quite far into the paper, so it's going to be slightly tricky. We start with this quadratic here, and we're asked to find the value of p and the value of q once we've rearranged that quadratic into a format that looks very much like completing the square. So 3 parts to this question. First part, find the values of p and q. In part B, we have to find a discriminant of this quadratic, and then in part C, we are sketching that quadratic. So it is very reminiscent of a completing the square question, although the format's slightly different. So for 3 marks in part A, find this p and q. So I'm told that 4x minus 5 minus x squared is equal to q minus x plus p squared. Now you can multiply out the right hand side here and gather up the terms and then set the coefficients equal, but what I'm going to do is multiply both sides by minus 1, because this is a negative quadratic and there's on the left and also a negative quadratic on the right. If I multiply both sides by minus 1, I'm going to turn this into a positive quadratic, making it easier to find the coefficients. So if I multiply both sides by minus 1 and then rearrange into a format that I'm more familiar with, I will get x squared minus 4x plus 5 on the left, and I'll also get x plus p squared minus q on the right. So it's been multiplied by minus 1 and just moved around a bit. Okay, now I can see a completed square format, which I'm much more familiar with. So let's complete the square on the left. We always take half of this value. So I start with this. I multiply this out first just to see what I'm left with. I'll have an x squared. I'll have 2 minus 2x terms and a positive 4 on the end, which simplifies to x squared minus 4x plus 4. Okay, so I can say that x squared minus 4x plus 4 is equal to x minus 2 squared. And I'm writing it this way around just for those of you that can't see that straight away. And then I'm going to add 1 to both sides so that I can explicitly state that x squared minus 4x plus 5 is equal to x minus 2 squared plus 1, excuse me. Okay, so now I've got my x squared minus 4x plus 5 in a completed square format. And if you want to, you can go back to multiplying both sides by minus 1. So let's go back to the original. 4x minus 5 minus x squared is equal to minus 1 minus x minus 2 squared. So your q is minus 1 and your p is minus 2. So that's part A complete. So part B, calculate the discriminant of 4x minus 5 minus x squared. So let's write it in the descending powers of x so that we can identify the a, the b and the c. So we can write it like that. I'm not multiplying both sides by minus 1 this time because there is no both sides. There's a quadratic, so it's an expression. Multiplying this by minus 1 actually changes the expression, so we have to leave it. But we can write the terms in a different order. So a is minus 1, b is 4, and c is minus 5. Okay, and the discriminant is, by definition, b squared minus 4ac. So what is b squared? That's 16. Minus 4 times minus 1 times minus 5. There's 3 negatives in there, so that's going to come out negative. It's a negative 20. So it's 16 minus 20, which is minus 4. The discriminant is negative. So that is going to suggest that our quadratic doesn't have any roots. So for part C, I'm going to sketch the curve with this equation, showing clearly the coordinates of any points where the curve crosses the coordinate axes. And I'm going to use this format of the original quadratic, so no multiplying by -1. There's the original quadratic there. So in this format, I can perform transformations to the graph of x squared. So if we imagine that the original graph of x squared looks like this. So if I replace x with x minus 2, I move my curve to the right by 2. So this is x minus 2 squared. Now, it's actually a minus x minus 2 squared. So that's at 2. So let's flip that. So here's minus x minus 2. And all I need to do, it should be a squared. All I need to do here is subtract 1 from this. Oh, there it is. Subtract 1. So move it down by 1 to complete the full curve. So let's do this neatly. X and y. So we've got 2 minus 1 here. We have no roots, which we were expecting. That's an awful quadratic. Let's try that again. It's a bit better. Okay, and then we need to know where we cross the y-axis. So this is when x is equal to 0. So if I put x equal to 0, more easily done in this one. So x equals 0 in there makes that -5. So we're crossing the y-axis at -5. And that completes the sketch and concludes the question. So that's all done. Check out studywell.com for more.